Alrighty, so today we're going to talk about empirical and molecular formulas and the difference and similarities between the two and how to actually solve problems using both of them. So let's just talk about examples first, okay? So let's say I gave you our good friend glucose, C6H12O6, okay? Glucose, this is the molecular formula for glucose. It tells us how many atoms of each type of the elements are in this one compound, in this one molecule. However, you might notice that each of the subscripts here could be simplified. 6, 12, and 6 are all divisible, can all be reduced by 6. And if we reduce them all, okay, we get CH2O. This is the simplest form, the most reduced form of glucose, and this is called the empirical formula. The empirical formula is the simplest, most reduced form of a chemical formula. It also tells us the ratio between each of the elements in the compound. So this tells us in any molecule that has this ratio of elements, there will be 1 carbon for every 2 hydrogens for every 1 oxygen. So what does that mean? That means that we could have multiple compounds with the same empirical formula. We could have C2H4O2. We could have C3H6O3. We could have C4H8O4. All of these have the exact same ratio, i.e. the exact same empirical formula, even though they are completely different molecules. They might have different boiling points, different melting points, different bonding properties, etc. But what they do have in common is the same empirical formula. So let's figure out how can we figure out the empirical formula in a problem. So problem number 1 here asks, a compound was analyzed and found to contain 13.5 grams of calcium, 10.8 grams of oxygen, and there we go, 0.675 grams of hydrogen. And we want to know, what is the empirical formula? What's the simplest, most reduced formula of this compound? So what's cool is chemists, let's say you were walking home from school, you found this sample of rock and it looked really cool. We're going to talk about the tools that chemists have to figure out these masses, 13.5, 10.8, 0.675. For now, don't worry about that. Let's just say you did all that testing and you figured these masses out. Well, our first step to figure out the empirical formula is to calculate the moles of each element. So let's do calcium first. Well, if we have 13.5 grams of calcium, we want to convert that to moles. So we'll do 1 mole of calcium is, it says mile, it looks like 1 mole, we know is from the periodic table 40.1 grams. So we cancel these out. This is going to give us a final value of 0.337 moles of Ca. We do the same thing for oxygen, for hydrogen. So for oxygen, we have 10.8 grams of O. We'll convert that using the molar mass of O. 1 mole of oxygen is 16 grams, periodic table. Cancel those out. This is going to give us 0.675 moles of O. And then we'll do the last element we have in this compound is hydrogen, 0.675 grams of H times 1 mole of hydrogen is 1.01 grams of hydrogen. Multiply these across, this gives us 0.668 moles of H. Now, we have calculated a ratio between the moles of each element in this compound. But these are kind of nasty numbers. We want to get integers. So all we have to do now is divide each value by the fewest number of moles present. So, what element has the fewest number of moles? Well, it's the element that has the smallest number, calcium. So we're going to divide every number by 0.337 because that's the smallest number of moles I have out of all of these elements. And when I do that, for calcium this is going to give me 1, for oxygen this is giving me about 2, and for hydrogen this is giving me about 2. So this means that my ratio of elements to each other in this compound is for every 1 calcium I have, I'm going to have 2 oxygens and 2 hydrogens. So this is the empirical formula. This is the simplest, most reduced formula. This is more commonly written as CaOH2, calcium hydroxide, and boom. We just figured out what the empirical formula is just based on the masses that were given to us up here. How cool is that? You might be wondering, man, how do I figure out the molecular formula? Well, that's essentially what we're going to do next. But let's try the similar type of problem, but it has some slightly different numbers. So number 2 says NutraSweet is 57.14% carbon, 6.16% hydrogen, 9.15% nitrogen, and 27.18% oxygen. A asks, calculate the empirical formula for NutraSweet. So if we're following the same setup that we did before, we're going to need to figure out the moles of each element from the number of grams. But the problem is we're not given the number of grams. We're given the percentages of each element. So we're going to make an assumption. We're going to assume, okay? We're going to assume that you have 100 total grams of sample. So that means the mass of all of the elements added up equals 100 grams. I picked that number out of random. It doesn't have to be 100. You could do 10 or 50 or 10,000. But what's cool about 100 is it allows me to convert percentages to grams very easily. So if I'm going to do the same thing I did before, where I figure out the number of grams of each element and convert them to moles, I know that if I have 100 total grams, and 57.14% of that 100 is because of carbon, I know my mass of carbon is 57.14 grams. Simple. That's a G. And then we'll do the same thing. We'll convert this to moles. 1 mole of carbon is 12 grams of carbon. These cancel. That's going to give me 4.76 moles of C. We do the same thing for hydrogen. I have 6.16 grams. 1 mole of hydrogen, and you guys should be able to do this in your sleep by now. 1.01 grams. That's going to give me 6.10 moles of hydrogen. Nitrogen has we have 9.52 grams of nitrogen. So we'll convert that. 1 mole of nitrogen weighs 14.0 grams. Multiply that across, divide, gives me 0.68 gram. Oh, excuse me. Let's erase that. Beauty of this. Moles of nitrogen. And last but not least, oxygen, 27.18 grams. We'll convert that. 1 mole is 16 grams. This is going to give me 1.70 moles of oxygen. So now I do the same thing I did before. I divide every value by the fewest number of moles that I have. In this case, the fewest number of moles I have, the smallest is 0.68. So I'm going to divide every value by 0.68. And now I'm going to get some values of 7, 9, 1, and 2.5. Great, except I have a decimal down here. We never in a chemical formula see a decimal. You never see, something that, looks like this. You never see C2.5, gosh, that looks ugly, C2.5 H10. We never have decimals. We always have whole numbers. So what we need to do is we need to multiply these values by something that will get them all to turn into a whole number. Well, the easiest thing that we can do here is multiply them all by 2. So if we multiply 7 times 2, that's going to give us 14. 9 times 2 is going to give us 18. 1 times 2 is going to give us 2. And 2.5 times 2 is going to give us 5. So these are the final values that I will use for my empirical formula. I'm just going to pull it up a little bit. What I would write here now, my final answer would be 14 carbons, so C14, 18 hydrogens, H18, 2 oxygens, O2, and 2 nitrogens, N2, and 5 oxygens, O5. Boom. There is my empirical formula for NutraSweet, the artificial sweetener that people put in their drinks. But let's say we want to figure out what the molecular formula is. Okay? So B says, find the molecular formula. The molar mass of NutraSweet is 294.3 grams per mole. I want to cross that out. Okay? This is a typo. We're going to pretend it says 600 grams per mole. So to figure this out, since we know the empirical formula already, all we need to do is take the molecular formula mass and divide it by the empirical formula mass. So the molecular formula mass is what's given to us in the problem, which is 600 grams per mole. And we're going to divide that by the empirical formula mass. The way we're going to get that is just how we would get the molar mass of any compound, except now the compound is this guy. That we just figured that out. So, if we figure out the mass of this, 14 carbons, 18 hydrogens, 2 nitrogens, and 5 oxygens, if we add all those babies up, we'll get a nice, beautiful 294 grams per mole. We divide these, 600 divided by 294 gives us about 2. So that means the ratio that I need to multiply my empirical formula by is 2. So we'll take our values up here, C14, H18, N2, O5. We'll multiply all of those by 2, and we'll get our final molecular formula of C, gotta remember, multiplied by 2, C28, H36, 18 times 2, N4, and O10. So notice the ratio between the numbers of each of these elements is the same as up here, but in NutraSweet, based on the molar mass given to us, boom, that's the formula.